we started semiconductor electronics. Semiconductor. So semiconductor means it's a conductor as well as the insulator. That's why it's called semiconductor electron. Okay. In this lesson, so you are going to say about the electronics. Electronics become the part of our daily life. So electronics எல்லாமே இன்னைக்கு நம்ம daily life கிடையாது. So because we are using that laptop, cell phone, mixer, grinder and washing machine, everything is we are using the electronic things. Then washing machine and fridge, these are all the electrical things, but we are using that electronics in the board. So using that the electrical devices are working. So without electronic device, we are not lead to our life comfortably. So in this lesson, we are going to see that how it is works. Then what is the function of the electronics? How they are build the electronic device. So that things that we are going to see in this lesson. So that now we are going to see that evolution of electronics. So the evolution of electronics means how that electronics are evolved. So initially that 18th century, J.A. Fleming in 1897, he was followed by he invented the vacuum tube. So vacuum tube was produced by the J.A. Fleming, followed by the Lee Frost. The two scientists, they are producing the vacuum tube by using the electrical signals. After that, the new things are produced in a tetrode, pentode, diode. Diode means it's two things. It is anode and cathode is there initially. Then triode, pentode, tetrode. Tetrode means it is 3 electrodes like that. That pentode is a 5 tubes. So using that, they are producing the calculators. Yes, in 1897. After that, bipolar junction transistor was invented by Bardeen and Schottky in the year of 1948. So they are awarded the Nobel Prize in the year of 1956. After that, they are producing the found the germanium and silicon. Very, very, very large popularity in the electronics. After that only, that application of electronics are enormously increases. After the following years, they found the integrated chips. So initially they find the transistor, that is bipolar junction transistors. After that, they have invented the ICs, integrated circuits. The integrated circuits are produced from the year of 1958. That's capable of holding the several thousand electronic components that may be made by single chip or the small, medium, large, very large integration chips are produced in the by different countries. Then digital integrated circuits. So digital integrated circuits develop the architecture in the computers. So you know the Pentium processor. So initially the Pentium processor produced in the year of 1969 by Intel. So it produced the first microprocessor on the basis of integrated chips. So first and the electrode conductor, then diode, tetrode, pentode, like that the characters are produced. After that, the junction transistor are produced. After the transistor, they are producing the integrated chips. Then they are producing the microprocessor. So using that, we are using a different lab computers. Nowadays, that initially that produced computers are very huge in size. Nowadays, it's very small and simple. So for an example, you can say that computer, laptop, phone top, like that devices are produced. So next thing is the very small computer, that is 0.33 mm of very thinnest computer was produced by that IBM. So in this electronics lesson, we are going to see that how the transistor, microchips and other things are working on the basis of that electrons and other things. So in this lesson, we are going to see the transistors, diodes, integrated circuits, sensors, and active and passive components like resistor, conductor, capacitor, and transformers. So this chapter completely deals with the PN junction diodes and bipolar junction transistors. Okay. So next we are going to see so these are all the electronic devices which I are using in this. So energy band. You know that students, that electrons are revolves around the atom in a various orbitals. So there was from the nucleus in a various orbitals inside that atom. So it contains electron. That electron completely filled orbital is called core orbital, or the electrons are called core electrons. You know that. So the electrons are partially filled. That is, it's not completely filled. It's only partially filled. It's called the valence band. So the electrons are not completely filled. It's called the valence band. Okay. So the next thing is that electrons are not available in that orbital is called conduction band. So electrons can jump from valence band to the conduction band. At the same time, that electrons are which is all very close to the nucleus or the first orbital, second orbital like that. It will very attract a very large force acting on that electron is tightly bounded with the nucleus. That electron which is revolves around the far away from the nucleus, that electrons are loosely bounded with the nucleus. So when the energy given to the electron, it can jump from the one orbital to the another orbital. You know that. So here in valence band, it has a partially filled electrons are there. The partially filled electrons are used to conduct the energy. So it can jump from one orbital to another orbital. Suppose only one atom, you can consider only one atom. It has only one free electron, that is in the valence electron. Suppose another one atom comes closer. So what will happen? The two electrons are producing the two energy levels. So the electron can jump from any energy level between the two atoms. Suppose 3. So it has produced the 3 suborbitals. So that electron can jump from any suborbitals. So that large number of electrons producing in a different energy levels, that energy levels producing the energy band. So we are not going to say that it's a energy levels. So combining of all the energy levels, we can call it as a energy band. So the band of very large number of closely spaced energy levels in a very small range is known as energy band. So the band of very large number of closely spaced energy levels in a very small energy range is known as energy band. So there is an energy band. So it contains large number of energy bands. So energy bands and valence orbitals, that valence band, that unoccupied valence electrons. So electron can jump from the valence band to the conduction band. So that energy, can you see here, this is a conduction band, this is a valence band. So energy gap between the conduction band and the energy band is called forbidden energy gap. So EC is the energy of conduction band, EV is the energy of the valence band. So the energy difference between the energy of valence band to the conduction band is called forbidden energy gap. Okay. So forbidden energy gap. So when you are subtracted value EC minus EV, you will get EG. That is energy gap, or it's called forbidden energy gap. So you can calculate the value. So here next we are going to see the classification of materials. Then how we can measure the materials. So now we are going to see the solids. Solids can be classified into 3 types. One is the insulators, next one is conductors, third one is semiconductors. Here the energy gap is the indicator the unit of electron volt. You know that in the 7th lesson we studied that the energy level of orbiting electrons are measured in the electron volts. So here that energy gap, orbital energy gap is also measured in the unit of electron volt. So now we are going to see the insulators. So insulators, see here CV is the conduction band, CV is the valence band. The energy gap between the conduction and the valence band is 6 electron volt. So it's a very large energy gap. So it is not possible to electron jump from the valence band to the conduction band. Suppose you are supplying that energy to that electron, it is absorbing that energy, but it is not able to jump from valence band to the conduction band. So this is called insulators. So that resistivity of that range of the insulator is 10 to the power of 11 to 10 to the power of 19 ohm meter. 19 ohm meter. So next thing is conductors. So conductors, see that next picture. This is a conductor. So conductor. So here metal is the conductor. So here there is no energy gap between the conduction band and valence band. So the two bands are overlap each other. So that does not require any energy to jump the electron from valence band to the conduction band. it can easily passes from the valence band to the conduction band. That's why this is called conductors. All the metals are conductors, you know that. The resistivity of the conductor is 10 to the power of minus 2 to 10 to the power of minus 8 ohm meter. So that is the resistivity of the conductors. The last thing is semiconductor. See here, it's a semiconductor. Energy gap between the semiconductors, valence band and conduction band is very small. So that energy gap equal to 1 electron volt. Up to this, only it's 3 electron volt. Semiconductors have the that energy gap is less than 3 electron volt. So 3 electron volts, when we give the small amount of energy, the electron can jump from the valence band to the conduction band. In even ordinary room temperature, that electron can jump from the valence band to the conduction band. So very small amount of energy is enough to jump the electron from valence band to conduction band. So it is initially behaves like an insulator. When the temperature is increases, for an example, for up to 25 degrees centigrade, it is in a insulator state. Suppose the temperature is increases more than 25 degrees. So the electrons are jumped from the valence band to the conduction band. That the heat energy is absorbed by the electron. So it jumps from the valence band to the conduction band. So it's called a semiconductor. If it is an insulator, when temperature increases, it will become a conductor. So it's called semiconductor. The resistivity of the semiconductor is 10 to the power of minus 5 to 10 to the power of 6 ohm meter. So here, when temperature increases, the resistivity of the semiconductor is decreases. So it is inversely proportional to each other. Here, it has a negative resistivity. Then, it has a negative resistivity. The most important element, semiconductor materials, silicon and germanium. So these most important materials, the semiconductor materials are germanium and silicon. The forbidden energy gap of the germanium and silicon is, for silicon, this 1.1 electron volt, germanium 0.7 electron volt. So when you give the very small amount of energy, electrons can jump from the valence band to the conduction band. So it's called classification of materials. So we classify the materials: insulator, conductor, and semiconductor. So next we are going to see that semiconductor